I'm Martin Kinsella, Director of Advanced Materials and Process Technologies at Comau. We're here in the Innovation Centre. We've got an Innovation Centre, a showroom, research and development area. We've got laser labs, we've got materials science labs, we've got metrology, we've got all aspects. So this is not only a showcase area, and a world-class showcase, I might say, but it's also an R&D centre, a testing area. We've got training going on, we've got, let's say, development work going on, but we're also doing now in terms of our 360 process. So we can look at a process, we can develop that process, understand how it's going to operate, and then through our materials labs, etc., we can then section, polish, understand exactly what's taken place with that process. The industry are investing heavily in terms of new materials because what was available a number of years ago won't meet the targets. Okay, so they're having to reduce the weight dramatically. Let's say a 10% weight reduction in the vehicle mass gives approximately a 3 or 4% improvement in fuel economy. So therefore you can see that the quick wins in terms of the let's say the technology and the new materials, the OEMs are driving towards that. So it's a very interesting market at the moment because the OEMs are looking at all their aspects of the product. So not only what we call the body in white, which is the frame of the vehicle, but also in terms of engine technology, drivetrain technology, even down to wheel and tyre technology. So technology in terms of roll and resistance and aerodynamics is playing a part in that target to meet the 54. A couple of major trends at the moment in terms of the automotive industry is the fuel economy and CAFE standards, which is a standard that's driving all OEMs across the board, doesn't matter whether they're low volume, high volume manufacturers, to improve their miles per gallon by various means. So that therefore drives new technologies into a smaller confinement. How those technologies work together is a key process. So could one impact the other? We need to understand and allow for that. We also then need to understand in terms of the maintenance and the throughput, how they affect each other and how we can then design a system to cater for that. We look at what we call, let's say, the manufacturability of the process. So can the different materials go together? What's going to join those different materials? Can the different joints and their configuration, do they assemble? You know, because it's important that if we have a product that we understand very early on, can it be manufactured? Here within Comau, simulation or virtual world engineering is mainstream. It's everything. For many years, we've driven ourselves to be at the forefront in terms of technology, to have it so we're actually producing a facility in complete virtual environment. Okay, and when I say complete, not just in terms of just the robot or maybe some of the tooling, complete in terms of cabling, auxiliary mounts, fence line, what we call HMI, human man interfaces, etc. Every part of the process, because unless you have everything in the process, the parts you don't have are normally the parts that are going to cause you the problem. So simulation and digital and virtual world are key components. The industry now has got a target that's not going to change. That's one thing that's not going to change. Yeah, and the industry have to develop solutions and processes to meet that target. That's driving us all to work very closely together. And I think really the industry needs to be more collaborative in terms of the working together, the sharing of knowledge, etc. Because there's some very good knowledge out there, and by working together, it's ensuring that overall the industry improves.